Okay, welcome viewers. Today we're going to be going over reflectional, rotational, and point symmetry. This is an animation behind me that gives you an example of reflectional symmetry. So, reflectional symmetry happens if you take a figure and you fold it over and it maps onto itself on the other side. You've seen this a lot in science classes with maybe pictures of like flowers, just things that you find in nature, probably in middle school. So that's your example for what reflectional symmetry looks like. Where's my mouse? Here it is. So now we are going to go to our first example that we've already done in class. And we use the line drawing tool to identify lines of symmetry. So, and obviously mine aren't perfect, but if you take the figure and fold it over and it maps onto itself, that is a line of symmetry for that figure. So this figure has 4 lines of symmetry because you could actually fold it diagonally as well and it would map onto itself. So the next one kind of looks like an infinity sign there. Okay, we could fold it this way or this way. So this figure has 2 lines of symmetry. Any questions on lines of symmetry? All right, we are going to now move to slide number 43, and we're going to take a look at rotational symmetry. Rotational symmetry is if you have a figure and you rotate it a certain number of degrees and it maps onto itself. It looks identical. So this figure, let's draw the lines of reflection first. If I go construct and line and just draw a couple. There we go. Actually, I'm gonna, how do I remove it? Oh, there we go. Okay. If I take this figure and draw lines through all the vertices, okay, we can see that this square is broken up into 4 sectors that rotate. For example, if I start here, if I take the figure and I rotate this vertex to match this vertex, I've rotated the figure 90 degrees because this circle has 360 degrees, and we just broke it up into 4 pieces because there are 4 vertices. So this square has rotational symmetry at 90 degrees and at 180, and usually we stop at 180. And there's a specific name for rotational symmetry at 180 degrees, and that is point symmetry. We're going to go over in just a minute. So how many degrees is 1 turn of a square? Well, that's just 360 divided by 4, 90. Go to slide number 44. How many degrees is in 1 term of a hexagon? Now this is a regular hexagon, okay? So each of these vertices are exactly the same distance away from each other. So if I go from this vertex to this one, how many degrees is that? Well, this is a hexagon and there are 6 vertices. So that means if I take 360 and divide by 6, I'll get the number of degrees. So we can do that on the calculator here. 360 divided by 6, and it gives us 60 degrees. So this hexagon has rotational symmetry at 60 degrees, 120 degrees, and 180, and that's called point symmetry at 180. And I'll show you that in just a second. Go to slide number 45. Stop me if I'm going too quickly. We're going to do some matching here. We are going to separate these figures into reflectional symmetry only, rotational symmetry only, the figures that have both and the figures that have none. I'll start with the square. I could draw lines of symmetry, so that has reflectional symmetry, but I could also rotate it, which we saw in our last couple examples. So it's got both, the square. This figure right here, which is a parallelogram, if I flipped it upside down it would look exactly the same. So this figure has rotational symmetry at 180 degrees. That's called point symmetry. Just a vocabulary term. So that's got rotational symmetry only. Now I couldn't take this parallelogram and fold it anywhere to make it map onto itself. So it does not have reflectional symmetry. Good on that? All right, the heart can be folded right down the center. That's got reflection symmetry only. This one's got none. The butterfly can be folded in half. There we go. This blue figure right here that looks kind of like a pinwheel, we can rotate that 90 degrees and have it map onto itself, but we can't fold it and have it map onto itself. So that figure has just rotational symmetry. This one's clearly got none. The circle has both, because we can fold it and we can rotate it to look exactly the same. How am I doing? Rotational symmetry, no symmetry. What do you think? Do you guys think this pentagon is regular or not? Because it clearly has reflectional symmetry, right? We could fold it over, but I don't know. These lines look kind of a little bit longer to me. What do you think? I could go either way. Do you think it's a regular pentagon or not? If it's regular, then we could say it has rotational symmetry. But if it doesn't look regular, like, do you think these lines look longer? I don't know. What do you think? It kind of does look a little longer. So let's just put that one, let's say it's not regular, which then means it's just going to have reflectional symmetry. If it was regular, then all these vertices would be the same distance away from each other. It could also have rotational symmetry, but I think we all agreed that it's not regular, so it's just going to have reflectional symmetry. How are we doing? All right, that is slide number 45. We're going to do one more slide. We're going to go to slide number 46. So this is a summary of the types of symmetry that we're learning about. Line symmetry, okay, which is reflectional symmetry. We already kind of went over that. Rotational symmetry, which we just went over as well, okay? Point symmetry is if you take a figure, it's basically just a figure that has rotational symmetry at 180 degrees. So if you take a figure and you flip it upside down and it looks exactly the same, then that figure has point symmetry. So let's think of some letters that have point symmetry and draw them on the last slide here. For example, I, and we're doing capital letters, okay? So I, you could take I and flip it upside down, rotate it 180 degrees, and it looks identical. So the letter I has point symmetry. What are some other letters that have point symmetry? If you flip them upside down, they look exactly the same. X is a good one. X. What about B? If I flipped B upside down, would it look the same? No, it wouldn't. So B isn't going to work. What about O was a good one. O is a good one. H. O. Let me draw H. What about S? Oh, that's the wrong tool there. It would work, right? If you flipped it upside down. I mean, if it was the right font. S?
Yeah. Oh, no, if you flip it upside down. Oh. Yeah,
We're good, right? Any others? Z. Okay, so I think we understand what point symmetry is now. It's just a vocabulary term for rotational symmetry at 180 degrees. It will be on your SOL. And that's all for today.